Hi everyone, in this video we are going to explore about the PIC microcontroller addressing modes. So PIC microcontroller addressing modes, it is a different types of addressing modes available in this. The first one is the literal addressing mode, direct addressing mode and indirect addressing modes are available. First we see about the difference between the literal addressing, direct addressing and indirect addressing. So in this picture, we see that it is a directly dialing a fixed number like 555-234. The data is part of the instruction itself. So it means a constant value representation. The second one is a direct addressing. So looking up John in contacts and dialing his number. The instruction holds a fixed address from we selecting the contacts of our cell phone. The next one is the indirect addressing. It is looking up the John's brother via John's contact entry. The address is dynamically helped in a pointer. First we see about the literal addressing mode, or it is called immediate values. This mode embeds the data value directly within the instruction. So it is used for loading constants into register for immediate operations. The concept behind this is data is literally part of the instruction. That means it is a constant value. So for storing this data, we don't need any separate memory lookup as needed. Example opcode move LW, K. So in this move literal value K to the work register. For example, if we load the 0x0 loads means the 020 is loaded in the work register. So the main characteristics of the literal addressing mode is it is a single instruction mode and it gives the fastest execution and executes in only one cycle, and it is an efficient one for constant value uploading. Second one is a direct addressing mode and it is defined as a fixed locations. The instruction directly specifies the exact memory address to access. So this is ideal for accessing the registers. The concept behind this direct addressing mode is the instruction contains the precise memory locations or memory space for data access. So it is use cases accessing general purpose register, that is GPRs, and special function register is it is a SFRs like port B, port A and port C. So coming to example part of this, move WF, F. Here the value of F is moved from work register to the file register location. So for example, move WF port B copies W to port B. So performance wise, the direct addressing mode gives it is the fastest one, and as the address is explicitly provided within the instruction, and it is used to avoiding calculation overhead. And third addressing mode is an indirect addressing mode. It is an indirect addressing mode and it is a dynamic pointers one. The concept behind this is the FSR file select registers holds the memory address, so the data is accessed via the pointer. The key registers are FSR stores the 8-bit memory address. For example, 0x04 for PIC16, it acts as a pointer. The key registers is not a physical register. It is an alias used to read or write the location pointed by the FSR. The primary use is iterating through data structures, arrays and buffers, ideal for dynamic memory manipulation. The indirect addressing mode, FSR and INDF in action is the set SFR and access INDF register and increment SFR. So from this we have to increment the FSR to move the next memory location for sequential processing like arrays. For example, to copy data from 0x0 to 0x21 on a PIC16 means you would load the value of 22H into 020 location into FSR. and then we have to read the 20th location value, that is a 22, to work register, and then move or copy the content of file location 0x20, that is a 22 value, into port B or port C, any special function or any general purpose registers. Thank you.